Who is this?
Only schedule less than 3 hours at Zimba Masha won't spread in.
Sound is more than that's why I don't like it. That means that I said he gave Bobby to give it to me. Guys, not yet. Those people talking.
Okay, so good morning, everybody. Good morning, everybody. Please, who are these people dropping attendance? Yeah. Hello, please. If you drop any attendance here, I'm kicking you out. It means you're just looking for the first time. If you drop any attendance, it's and this is mute yourself and removing all of this and be removing people this morning. So before I remove you, I'm removing all of you now. This is disturbing. Addition out. Mute yourself as you join, otherwise I will remove you. Mute yourself otherwise I will remove you. As you join, you can't be disturbing. Learn lecture rules and regulation. Good morning, ma. I think I should use the first 5 minutes to remove those ones that could not mute themselves. You are here. Mute yourself.
Oh my God.
I sent you something on your WhatsApp. Go and fill it up for your state of origin. Fill it now. Now, like, so that you do it, so that you're able to get it.
Okay, sorry. Thank you for that. I said I'm standing in for a senior colleague who is unavoidably absent or not chanced to have this class this morning. So I'm going to stand in for him today and today only. Subsequently, I'm sure there will be a chance to take his class. I think I'm recording the lecture already. Please don't drop attendance. If you drop attendance, I'm kicking you out. Hello, who are these people? Dropping attendance here. Let me remove 1 or 2 people again. Nobody drops attendance. We get. Okay, I'm back. Sorry, let me go back to the slide. So we are going to, like I was saying, can you guys hear me, please? If you can hear me, just say yes so that I can continue. Okay, thank you. So today, without wasting time, let's start the lecture, which is cellular reproduction and heredity. The cell needs to reproduce. From our knowledge on of cell theory, we said one of the cell theories is that cell is the basic unit of life. Another one also says all cells come from pre-existing cell, and that was accredited to Rudolf Virchow, RUDOLF, Rudolf Virchow, VIRCHOW, Rudolf Virchow. Now, that statement stopped there in your secondary school biology, that all cells come from pre-existing cell. But how do cells come from pre-existing cells? It's that will be a way whereby one cell will arise from another one, right? Is it by magic? No. So here we are adding to that statement to say that all cells come from pre-existing cells by cell division. So the means whereby all cells can only come from pre-existing cell is by cell division, by a cell reproducing itself, right? So that is what we mean by cellular reproduction and heredity. Heredity is that aspect of biology that deals with transmission and inheritance of traits. So we are going to be looking at these two topics under this theme of this class, right? So all cells come from pre-existing cell by cell division, right? Or cellular reproduction, right? What are the types we have? We have mitosis and meiosis, right? But before a cell divides, it undergoes a stage of preparation, so that is known as the cell. So the cell cycle is that growth, is that stage of growth or the stage where the cell prepares to divide. You are going for war. You need to prepare for that war. You are going on a vacation. You need to prepare for the vacation, right? You are getting your visa, you are getting your passport ready, you are booking your ticket and all of that. So that is what the cell is going through. It doesn't just go into division like that, right? Prepares to divide is known as breaking. It might be my network or yours, and I think that will be better along as we continue. Breaking of voice might be as a result of network. I can't hear well. Can you hear now? I'm sorry if that is the case for everybody. Maybe it might be network issue. Let's just hope it gets better. You can't hear anything again. Oh. How about now? Is it clear now? We can't hear you, sir. I'm not muted. What's wrong? Is it the network? Is that bad? I don't want to log out of this place, or else we may have to set another Zoom. So let us just try and see whether it will get better. My voice is cracking. Oh, maybe it's the network. So I'm sorry. Let's just continue, please. Okay, please drop. Let's leave the message. Let's leave the message. I don't know. It might be network. Everybody is saying they can't hear. So what do we do? Should we leave here and set up another Zoom link? If it is network, the problem will still resurface. You can't. I'm trying to see now. How about now? Can you hear me now? I can hear you. I can hear you. But it's breaking a bit. Please, let's endure for some minutes. It might get better. Okay, please leave the stage where the cell. I think my network is a problem this morning. I don't bargain for this morning. No. I don't bargain for this morning. I want to have a seamless class. Okay, we said the cell cycle is that ordered sequence of events that precedes cell division, right? Like the cell is trying to divide, then it needs to undergo certain stages, certain steps, certain preparation stages for it to divide. And I said basically the cell cycle is further divided into three. We have the interphase, we have the M phase, which is mitosis or the actual division stage, and we have cytokinesis. Cytokinesis is a process whereby the cytoplasm of the cell divides, right? After the content must have divided, then the cytokinesis is a process that divides the cytoplasm so that you can have your how many number of cells that you are bound to have depending on the type of cell division. For mitosis, you have 2, and for mitosis, you have 4. Okay, so we said the cell cycle is divided into 3, the interphase, M phase or mitosis and cytokinesis. The interphase is further subdivided into 3. You have the G1 phase, the S phase, and the G2 phase, right? So let's see what happens in each of the stages. So the cell cycle make up the interphase, these 3. make up the interphase, which accounts for different events that occur between cell divisions, right? Then this slide shows the different stages of the cell cycle, basically the interphase, right? So we have the interphase encompassing these three, G1, S, and G2, right? The cycle is as indicated by this arrow, right? You have your G1, you have G2, and you have G1, you have S and G2. Then you have mitosis and cytokinesis, like I said earlier. So this is basically the cell cycle. And if you observe closely, you see that this figure that looks like a pie chart is unevenly distributed. That is, you have like your interphase taking almost 95% of the cell cycle. That is your G1, your S, and your G2 phases taking about 95% of that cell cycle. So the interphase is that period where the cell spends most of its life prior to cell division. The interphase is the phase or stage where the cell spends most of its life prior to cell division. That is, it is the longest of the three. We said cell cycle is divided into three: interphase, mitosis, and cytokinesis, right? So interphase takes the largest chunk of the time spent during cells in the cell cycle. Then followed by the mitosis, and the cytokinesis is the least among the three stages of the cell cycle. Then you have the G0 phase, where that is also regarded as the cell cycle arrest. Here, the cell is not dividing, is not making proteins, is not synthesizing anything. It's just in its quiescent phase where it is resting, or not really rest, because it is carrying out metabolic activities, but it is not just doing anything. It's not making proteins, it's not synthesizing organelles, as you shall see. So what happens during the G1 phase? Like I said earlier, this cell cycle is an ordered sequence of events. So you have G1 as the first, followed by S, followed by G2, then mitosis, which is the actual cell division, and cytokinesis, which divides the cytoplasm. So during the G1 phase, the cell is making cellular content, excluding the chromosomes, right? So all the cellular contents, like the cell needs some proteins, some organelles, are made during the G1 phase. As an assignment that you are going to do in your notes, I would like you to look at G1 and G2 phase, right, and see what organelles are made during the G1 phase and what organelles are made during the G2 phase, because both phases produce organelles, but different organelles are produced in each of the stages. Then the S phase is S for synthesis. G1, that is growth 1 or growth phase, S for synthesis, G2 for growth phase 2. So during the S phase, the cell chromosome is duplicated, right? So that, like, I think during our class on replication, we said that cell DNA replication takes place during interphase. And I said that stage of the interphase is the S phase, S for synthesis, right? So S phase is that stage where the DNA of the DNA content of the cell is duplicated or synthesized, or what's another word can we use? Like you are producing more copies. It's just like you have a copy of a note and you want to give to two people, right? But you have just one. What do you do eventually? You make copies. So the S phase is like you are making photocopy. So this phase can be likened to a photocopier machine, whereby the cell is making more copies of its DNA, so that the resulting daughter cells after the division stage can have. Please stop dropping attendance. These people, you are distracting with that chart. So that phase is just like you are making more copies of the DNA content, so that the resulting daughter cells can have enough and exact number of copies of DNA, right? Then the G2 phase, the cell double checks, in quotes, the duplicated chromosomes and making any necessary repair. So the G2 phase is where the cell confirms that, okay, because that is the stage that precedes mitosis, division. After that stage, the cell is going to divide. So it's confirming, have I made enough protein? Do I have enough organelles so that when I have my daughter cells, everybody will have their nucleus, their Golgi apparatus, their mitochondrion, what have you, right? Then it is double checking for error in the DNA synthesis or DNA replication stage. That is the S phase. And I think we have dealt with DNA replication and how the process ensures fidelity, that is, confirms their error, and if there is any error, it is repaired. So that is the cell cycle in summary. G1, the cell is growing, is making proteins and some organelles necessary for division. S phase, the cell is duplicating its DNA contents. G2 phase, the cell is double checking whether everything is necessary before I go to war, in quotes. Okay, this is another slide that is summarizing what you have said about interphase. It is the highest metabolism. G1, protein synthesis and growth lasted for about 9 hours. Then we have preparation for DNA replication, differentiation, and what have you. S phase, there is DNA replication. G2 phase, there is more proteins and organelles are made. Like I said earlier, you have organelles and proteins made during G1 and G2 phase. And specifically, I'd like you to find out what organelles are made during S1 phase, during G1 phase, and what organelles are made during G2 phase. Then we have the G0 phase that some people refer to as the resting phase, but actually the cell is actually undergoing normal metabolic activity. That it's not making DNA, it's not making protein, it's not making organelles, it's just, in quote, resting, right? Then we have the M phase, M for mitosis, right, which is the actual cell division stage. All of these G1, S, and G2 is preparing the cell for division. M for mitosis is the actual cell division stage. So mitosis is a duplication process that produces 2 daughter cells, right? 2 daughter cells are produced during mitosis, and these daughter cells are diploid. That is, they have the full chromosomal complement of that organism. For instance, humans have 46 chromosomes. So if any human cell undergoes, any human somatic cells undergo mitosis, is going to have diploid cells. Now, I introduced the word somatic, right? The cells of the body can be categorized into 2, depending on whether they take part in reproduction or not. Those ones that take part in reproductions are known as sex cells or gametic cells, or the gametes, and there are just 2 in the body, your sperm cell and your egg cells. All other cells of the body, about 200 of them, are all somatic cells, and these involve your skin cells, your liver cells, your hepatocytes, your white blood cells, erythrocytes, your lymphocytes, all cells of the body, the rod and cone cells of the hives. All of these are somatic cells. That is, they are cells of the body, bodily cells. They don't take part in reproduction. So all of these will undergo mitosis. They will reproduce. They will arise from pre-existing cell by mitosis. That is, somatic cells undergo mitosis, while gametic cells or sex cells undergo meiosis. Now, these somatic cells that undergo mitosis, we said only 2 are produced per division. So if a somatic cells undergo mitosis, is going to give 2 other somatic cells of its kind that have the same chromosomal complements as the cell that undergoes or underwent the division, right? So, for instance, if the liver cells divide once, you are going to have 2 liver cells. And these 2 liver cells we have in humans now, we have 46 chromosomes each. So that is what we mean by they are copying their chromosomes, because it is what you have here that you are giving into your daughter cells. So the same number of chromosomes that you have in the parent cell that is undergoing mitosis, exact number you have in the each of the two daughter cells that are produced. Another feature of mitosis is that the daughter cells that are produced look exactly alike like the parent cell that gives rise to them. So we refer to them as clones, like they are clones of their parents. There's no difference, there's no variation, except there is mutation. I've told you what mutation is all about. Mutation simply means change in genetic sequence of an organism. So except mutation sets in that changes maybe one A to T, except that daughter cells from mitosis they are clones of their parents. They are alike. If the parent has one disease in one locus, the daughter cells, the two of them, will have that disease. If the parent cell is big, the daughter cells will be big. There is no variation in mitosis except by mutation. Okay. So, and this process is very controlled. There are checkpoints, right? Before G1 to G2, before G1 to S, we have checkpoints. Before S to G2, there are checkpoints. Even before G2 to mitosis, there are checkpoints. So it's a controlled process. So if these processes fail, then you have uncontrollable cell division that we refer to as cancer. So cancer is when cell continues to divide, metastasis, uncontrollably, because the process is a controlled one. So if that process of controlling divide, don't divide, rest, go into cell cycle, if there is no check, if those checkpoints fail, then cancer results. Then the process of mitosis, of course, involves two processes. You have karyokinesis, which is the division of the nucleus, and cytokinesis, which is division of the cytoplasm. So karyokinesis precedes cytokinesis. That is, the nucleus will first divide into 2 or 4, because meiosis gives 4 daughter cells, right? So the last thing that divides is the cytoplasm. So there are 2 processes to cell division. Number 1, karyokinesis, which is division of the nucleus, and the cytokinesis, division of the cytoplasm. So when the cytoplasm divides, you now have your 2 daughter cells. Okay, and we're going to see how all of this take place by God's grace today. Okay, mitosis occur in 4 phases. Some authors say 5, some say 6, some even break down these phases into subphases. For instance, for prophase, some we have early prophase, late prophase. Some have metaphase, then metaphase. Some have early anaphase, late anaphase. Some have early telophase, late telophase. Telophase is telophase, prophase is prophase, anaphase is anaphase. So for the purpose of this class, we are going to be looking at mitosis under 4 stages, your PMAT, the prophase, M for metaphase, A for anaphase, and T for telophase. Okay. This figure summarizes the different stages and what events happen therein. I think you have seen something like this before under the cell cycle, where this further brings out the M phase and shows, like I said earlier, this one has pro-metaphase, but let's not bother ourselves with that. Okay, so let's look at the 4 stages and see what happens in each of these 4 stages. Number 1 is the prophase, which is the first and the longest phase of mitosis. During this stage, the chromatin condenses, making the chromosome visible. Now, there is what we know as chromatin, right? Chromatin is a unpacked DNA, right? Chromatin is unpacked DNA. So when this chromatin becomes tightly packed and is now referred to, it now makes your chromosomes. And what are those things that make it to be tight or coiled together? You have your protein, histone protein, and chromatin is a complex of DNA and histone protein, right? So when they are now tightly packed, they now form your chromosomes. So chromatin is an uncoiled DNA, while chromosomes is a tightly packed chromatin. I think one of the, okay, maybe as an assignment, maybe you can go and read up chromatin, chromosomes, and chromatids. Chromosomes is a what's it called? A coiled chromatin or DNA with histone complex. DNA plus histone protein makes up your chromatin. And when these chromatin are coiled together, they make the chromosomes. And these chromosomes houses genes. Genes are made up of DNA. Chromosomes are found in the nucleus. So your genetic element, your genetic material, the DNA, is found in the nucleus. Also, there are some organelles that also have their DNA, like your chloroplast and like your mitochondria. They have their own DNA, and they are double membranous. Yeah, they have double membranes, and these membranes, during this prophase, the membrane break down, the nuclear envelopes will break down, the nucleolus will disintegrate, the spindle fibers are formed in the cytoplasm. So these are the features that describe the prophase of mitosis. We said the prophase is the first and the longest. During this phase, the chromatin condense and the chromosome become visible. And I've tried to explain what chromatin is, what a chromosome is, and what a chromatid is. Chromosomes has two arms, right? Each of them known as chromatids. So like this is, for instance, you have, this is this is, if you have your chromosomes like this, right? So each of these is known as your, this is a chromatid and this is a chromatid. And these two are known because they are from the same chromosome. And these points where they join is known as the centromere, the point of attachment of two sister chromatids. This is one sister chromatid, another sister chromatid. The point where they join, right, is known as the centromere. And it is not in all cases that they join at the middle. Some can join at the top, right? So, but wherever they join, we call that place the centromere. The centromere is the point of attachment of a sister chromatids. And we said that two chromatids make up one chromosome. So if you have 92 chromatids, how many chromosomes will you have? 92 divided by 2, 46, right? Okay. That is what, okay, maybe I should go further on this chromatid, because there are sister chromatids and there are non-sister chromatids. So this blue and red, there are two chromosomes. Each of these chromatids are sister chromatids. But when you now pick this blue here and this red here, these ones are non-sister chromatids, right? Because they are from the same, they are from different chromosomes. But each of these blue are sister chromatids. Each of these red are sister chromatids. But when you now pick one red and one blue, these ones are non-sister chromatids. We are going to see the significance of this when we get to meiosis. Okay, so that is basically what happens during prophase. Is the first and longest phase, the chromosome becomes visible. Then the nuclear envelope breaks down. That is at a later stage of prophase. The nuclear membrane breaks down. The spindle fiber are formed in the cytoplasm. Then after prophase, you have your metaphase. Metaphase here, the spindle fiber puts its chromatins, then the line along the equator. So when you are given a micrograph or a slide to observe under the microscope, and you begin to see some things that line up like this, like horizontally, right? This stage, like lining up this way. This feature highlights that your cell is at metaphase, right? The cell here is at metaphase. And this occurs by this, the spindle fibers are those yellow lines. These blue lines that you are seeing that are attached to the microscope, these are the spindle fibers. And over it there, you have your centrioles. This one here, these are the centrioles. And centrioles are seen only in animal cell, and they aid in cell division. I'm sure Dr. Adebeshi must have dealt with that during his class on cellular organelles. Okay, so that is metaphase. Now listen, this metaphase has many advantages, right? Number one, at metaphase, you can know how many chromosomes are there in a cell, because that is where the chromosomes are now distinct. Although they are visible at prophase, but not as visible as you have at metaphase. At metaphase, you can count how many chromosomes you have under the microscope, and what you just do is to arrest the cell that is dividing at metaphase using a drug known as a colchicine. Colchicine. So you use this drug to arrest the dividing cell at a metaphase. I said colchicine. I think there's another one that you use, but this is the most common. I think clomid. I'm not sure. I'm not sure. Maybe clomid is used for another thing. But colchicine is one drug that you can use to, when you introduce to the cell that is dividing, then the cell will stop divide. It is arrested at metaphase. It doesn't go to anaphase. So from here, you can prepare your slide, and by doing one or two things, in the lab, you are doing a research or experiment. Then you can view that slide under the microscope. Then you can now see how many chromosomes you have. You can count at metaphase. So if I ask you which phase, like maybe a scientist wants to determine the number of chromosomes in a dividing cell, what stage of the cell cycle will he or she target? That's an exam question. And this one is not on this slide. So that is why you need to come for class. And please don't, I said it's used to arrest. I did not mention cancer when I was explaining metaphase. So please, let's not drag ourselves back. I said you use metaphase to arrest the cell that is dividing, right? You use colchicine rather to arrest the cell that is dividing at metaphase, because you want to study that phase, right? And that phase, when you arrest that cell, it doesn't go to anaphase, and from there you can determine your chromosome number. Another feature is that you can determine any genetic anomaly or abnormality or disease chromosomally from this state, because, for instance, if a cell is supposed to have 46 chromosomes, each of them into different in pairs. For instance, your chromosome 1, you have one pair, that is 2 copies of chromosome 1, 2 copies of chromosome 2 down to chromosome 22. We're referring to humans now. Then 22 pairs of autosomes. Those ones are known as autosomes. We're still going to look at it, or Dr. Shifao. I may not get to that slide today, right? So we have autosomes. So chromosomes 1 to 22 are known as autosomes, and they occur in pairs. So you have 22 pairs, that is 44. The other 2, because a human has 46 chromosomes, 22 pairs, 44. 46 minus 44, 2. So the remaining 2 are the X and Y chromosomes, and these ones determine sex in an individual. Maybe you are a male or you are a female. Okay, so at metaphase, you can determine the gender of a child at metaphase. For instance, I said that the chromosome is visible at metaphase. So if you observe the chromosome at metaphase and you are seeing X and Y chromosome, that means that child is a boy. If you are seeing XX plus your 44, that is 46. That means this baby, unborn child, is a female, right? Then I said another feature of metaphase that you can use to determine genetic anomaly, or abnormality rather. So I said that these chromosomes occur in pairs, right? These 22 pairs of chromosomes, 22 pairs, right? Now, there are some chromosomes that occurs that have 3 copies. You call it trisomy. That have 3 copies, trisomy, and that is an anomaly. So you can count at metaphase. When you are counting, you can see that, okay, I'm expecting 46 chromosomes altogether, but I have 47. That is an anomaly. I'm expecting to see 46 chromosome in this dividing cell, but I'm seeing 45. That is an anomaly. So you can determine this at a metaphase. And one of chromosomes has occurs in a, what is it called, at a, as a trisomy is your trisomy 21. That is, you have 3 copies of chromosome 21, and that leads to what you know as Down syndrome. Down syndrome, right? Right. So that is the beauty of metaphase. Metaphase, you can study your cell deeper at metaphase. Okay, all you need to do is just to arrest that cell at metaphase by introducing colchicine. Okay, let's look at our neighbors on YouTube and see what they are up to. I hope they don't have any problem. Good morning on YouTube. Good morning on YouTube. Are they there? I hope we have people here on YouTube. Okay. Okay. Okay, let's continue. Let's continue. Okay, that is a metaphase for you, ladies and gentlemen. So let's go to Anaphase. And I said, I'm sure you know all the things I will say about metaphase. If trisomy is identified, well, you cannot correct it because it is genetic. So genetic diseases, except you go and genetic diseases are not, you cannot correct them. That is why it is good to avoid them. Because like trisomy 21, are you going to remove the chromosome 21, the extra chromosome from all the organism? Right? There are some, like if it is a point mutation, but here we are talking about a whole chromosome. If it's a point mutation, for instance, maybe only one nucleotide is affected, like sickle cell, you can think sickle cell, there's sickle cell therapy now where you can do gene editing. You can just remove that single nucleotide and replace it. But we're talking about a whole chromosome here that has thousands of nucleotides. How do you want to go about that? So there are some genetic diseases that most genetic diseases are incurable, right? You can only manage them. Okay. I said Down syndrome is as a result of trisomy 21, whereby you have genetic engineering. Okay, engineer is a process where the 3 copies of chromosome 21, right? And this results from non-Cytokinesis. So let's move very fast. We have less than 15 minutes. I would say I have a long way to cover. Okay, so we have Anaphase. At Anaphase, the spindle fibers begin to shorten, and this shortening of the spindle fiber, this shortening of the spindle fiber makes the chromosome to move. The sister chromatids are now separated because the centromere is now broken. Again, let me quickly make a. We have our that are joined at the centromere. So what happens, and here you have some spindle fibers that are attached, right? So what happens at anaphase is that these spindle fibers are shortened by a force. These spindle fibers are shortened by a force that, oh, you can't hear. My mic is not, please, it might be network. Let's just give it a time. I think, can you hear me now? Hello, can you hear me? Can you hear me? Okay. Okay. Thank you. Thank you. So we have our sister chromatids that are joined at the centromere, right? Please, thank you, thank you. We have our sister chromatids that are joined at the centromere. This is the centromere here, right? Where the two sister chromatids join. So, and we have spindle fibers. This here, the spindle fibers are depicted with these blue lines in this figure here, right? So the spindle fibers are attached to the centromere. So at Anaphase, these spindle fibers begin to shorten, right? Like there is a force that is pulling them to opposite ends of there's a force dragging it this side, there's another force dragging it this side. So what happens eventually is that the centromere will break. When the centromere breaks, then you now have your chromatids. You no longer have chromosomes. You now have chromatids. So these chromatids are now pulled to opposite poles of the opposite ends of the cell. Like one is going northward, the other one is going southward. Right? So that is what happens as anaphase. One, you can use to identify anaphase, a cell at anaphase, because you may be given these models in the lab to tell us what is happening in this phase. Something that looks like a V shape, like a V shape. When you observe under the microscope and you are seeing something that looks like a V shape with spindle fibers attached that is pulling them, that is what's it called? That is your anaphase. And V-shape form. It's like you have your sister chromatid. You now have something that pulls it in the middle. You know that it's formed like a V shape. Just like when you have your chain, your neck chain, your necklace, right? When you have your necklace this way, right? And you now draw it down like this, you will see that that necklace will form like a V shape over time, right? So it is the pulling of that spindle fiber to the opposite ends that makes your chromatids to look like a V shape. And you can also use this stage to determine how many chromosomes you have in a cell, because if you count the chromatids, for instance, if you count this one, there are 4 chromatids here, and we said 2 chromatids make 1 chromosome. So if you have 4 chromatids, that means if you have 8 chromatids, that means you have 4 chromosomes. If you have 4 chromatids, that means you have 2 chromosomes. Okay, that is feature of a anaphase. Now, the last stage of mitosis is your telophase. Telophase is simply the opposite of a prophase. So whatever events you have at prophase, you have the opposite at telophase. If you remember at telophase, please, who are these people dropping attendance now? These first timers. Who are you oppressing with attendance? Telophase is the reverse or opposite of prophase. So whatever you see happen at prophase, the opposite is a telophase. If you remember vividly, we said nuclear membrane begin to form, but here at prophase, we said nuclear envelope, and nuclear membrane breaks down. Here we said spindle fibers are formed in the cytoplasm, but at telophase, we said spindle fibers disassemble. So let's not overflog that. Whatever we have at telophase, at prophase, the reverse is at telophase. So whatever those things that you are making at prophase, you are breaking them or disassembling them at telophase. Whatever is formed at telophase must have been broken down at prophase. And now you can now have your 2 cells, right? You can now have your 2 cells at prophase. You can see the 2 resulting daughter cells are now formed at prophase because you have membranes that formed around each of these daughter cells. So by prophase, this must have by telophase, these cells, you now have your nuclear membrane that forms around them, right? So when that happens, you know that telophase has set in. Now, the only thing that is left is for the cytoplasm to divide, is for the cytoplasm to divide, which is we can now have your two daughter cells, right? And that process is known as a cytokinesis, which is the third phase of the cell cycle. Interphase, mitosis, cytokinesis. So cytokinesis is the division of the cytoplasm that gives rise to two daughter cells. It is the final stage of the eukaryotic cell division. It results in two separate daughter cells are identical, right? Animal cell to your left describe, right? So in animal cell, just like there's a microfilament ring that forms in the middle of that dividing cell, and this forms a furrow, like a furrow that invaginates the cytoplasm inward. It's just like maybe you take your sachet water. The network, if you can't hear me, it will get better. If I log out of this place, I can't join again. I need to set up another Zoom. And how am I sure my network will be better? Maybe I should change my location. Can you hear me now? How about now? You still cannot hear me? Hello, can you hear me now? It is not clear. Sorry, it will get better. Sorry, it will get better. Sorry, it will get better. Unfortunately, I can't control my network. Okay, so we have cytokinesis in animal cell, whereby you have a cleavage furrow that forms in between the dividing daughter cells, and this furrow forms and divides the cell into two. We said that cleavage furrow can be likened that when you have your pure water knife, right, with water inside, you now tie a rubber band around in the middle, and maybe something that can pinch it inward. Then you drag that in until your water cuts in the middle into two different nylons. So that is just a version of a cleavage furrow that cuts into two. But say you have a cell plate. Cell plate forms you have that forms around the cell plate into two. So you have cell plates in plant cell and you have cleavage furrow in animal. Sorry, I'm having issue with my network this morning. I'm having network issue this morning. And we have not even covered much. We have not covered much. We have a class now. Your class is 9 o'clock. Your class is 9. Okay, let me see where I stop so that at least so that is the cytokinesis in plant and animal cell. Then we have importance of mitosis. Mitosis is important for maintenance of chromosomal sets because you are having each cell set of chromosome duplicated by each successive division. So the chromosome number in an organism is maintained by that. Then it is important in growth, in repair, replacement of cells, and also in asexual reproduction. So that is mitosis and its significance. counts. So next class, by God's grace, Dr. So no, your next class, maybe Wednesday or Friday, I don't know, and start with a meiosis by God's grace. Can you go back to slide 13? Okay, maybe some people said they have a class. Let's not keep them. Let's not keep them here. So you can go for your class and you can unmute and let's if you have any question, you can ask your question. If you have any question, please ask the question.
Excuse me, sir. Please, sir. Right, pin 21.
The explanation of the cytokinesis of
Good morning, sir.
More. Okay, let me read the chat room. Maybe that will be better. Will the slide be given to us? Is Dr. Shifa that can decide that? But I think he should. I think he will give you the slide. I'm not sure. I can't decide for him. Slide 13. Somebody wants us to go back to slide 13. Slide 13. Okay. Which other comment do we have here? How is attendance going to be taken, sir? Is that your headache? Come again from the mitosis stage. Oh, the classes. Come again from the mitosis stage. Come again. I don't understand when I should come again. When will we begin practical, sir? When are you coming to campus, sir? Any information on practical, sir? I think the university has released a practical and exam guideline. So your practical will commence in April, but the process is underway. Like we're going to close the registration soon, but we understand that some people are still registering now. So we may want to, that's why we are extending that. So that is all I can say for practical for now. Explain mitosis again. The mitosis stage. Which of the mitosis stages? All the 4. Okay. Thank you, everybody. You can go for your class. What of our tests? Can you give us area of concentration? Area of concentration for your tests. Okay, everything we have done so far. That is the area of concentration. Cytokinesis. Cytokinesis simply, okay, prophase. Somebody said prophase. Prophase simply means the cell is the first stage of the cell division. The nuclear membrane breaks down, spindle fibers are formed, nucleolus disappear, and what have you. Then at metaphase, the cell line up along the equator, like the middle or center of the cell. And I highlighted the significance of metaphase to include the sex determination, the chromosome number determination, to diagnose genetic disease or anomaly. Then at anaphase, the shortening of the spindle fiber, and this shortening makes the centromere to break, and the chromatis now move to opposite ends of the cell, and the chromatis appear like a V shape under anaphase. As telophase, we said telophase is the opposite of prophase, and you have those events occur like your chromosome, the chromosome will condense, the spindle fibers will break down or disassemble, the nucleolus are formed, the nuclear membrane are formed, the nuclear envelope are formed. Then at cytokinesis, where cytokinesis simply means cytokinesis, division of the cytoplasms. Right? It's the division of the cytoplasm, and this separates the daughter cells into two, or divides daughter cells into two. And we said this process differs in plant and animal cell. In animal cell, there's formation of a cleavage furrow. And I explained that by maybe you take your pure water nylon that has content, that has water in it, and along the line, you put a rope in the middle of that pure water nylon, and you tighten that rope such a way that there is a invagination that is pinching inward of that pure water nylon. The pure water nylon is the membrane or the cytoplasm that you want to cut into two. So along the lines, you cut that cell into two. That is what cell cleavage furrow simply means. There is a microfilament ring that forms in the middle of that cell, then which forms a cleavage furrow that eventually divides the cell into two. But in plant cells, you have a cell plate formation. The cell plate forms, right, along the plasma membrane. Then there is nuclear membrane that forms around the cell plate. Then from there, the cell will divide around the middle lamella of the cell plate. Then we looked at the importance of what have you of mitosis. Then we said that we stopped here. The next class we start from here. Unfortunately, we can't cover much. So that is all we have done for today. Do have a wonderful day and stay out of trouble.